So now let's talk about pH balance a bit. So I talked about how the kidneys are a major player in pH balance. Let's talk a little more about pH balance. So most of your body, if things are in homeostasis, should be about 7.4 pH. That is kind of the normal happy pH. If you start going up above that, we're calling it alkalosis. Going below it is acidosis. If you get above 7.8 or below 7.0, that's getting incompatible with staying alive. Right, so it's really important that you keep your pH in this zone, and if it's getting down into acidosis, that you bring it back up. If you're getting into alkalosis, that you bring it back down and don't get into that extreme range where you're going to die. So let's talk about the different mechanisms your body has in order to maintain your pH balance. And we've seen them all now. There are three main mechanisms that work on different time scales. What is the kind of instant way to try to keep the pH in its target zone as different acids and bases are added? We saw like the very first week of class.
Buffer systems?
The buffer systems, exactly. So we saw very dramatically how regular distilled water, you add acids and bases, the pH went wildly up and down. When we used the buffers, you added the acid and bases and the pH didn't change much at all. There were phosphate buffers. It was what we used. Bicarbonate buffer is like in your bloodstream. Proteins actually act as buffers, like in your cells. A lot of them have the ability to act as buffers. So these are pretty much instantaneous. You know, you add some acid or base, they'll instantly, the weak acids and weak bases will either dissociate or reassociate more. The problem with these is there's a limited capacity, right? There's a certain amount, like we talked about, if I have like some weak acid like H2CO3 going into H plus, HCO3 minus, I can have this go more this way or more this way, but at some degree, at some level, or at some point, I'm going to run out of my reserve of weak acids and bases that make up my buffer system, and I will overwhelm its ability to adjust things. So this can't be the last or the only way to control pH. You know, it's kind of instantaneous as the weak acids and bases disassociate or reassociate, but it's going to depend upon just how much of the actual buffer compounds you have to make the adjustments. So this is just our first line of defense. Second line of defense. We also talked about your respiratory system. So this is going to depend on the way carbon dioxide is being transported in your bloodstream. Remember, we talked about CO2 with the enzyme carbonic anhydrase found in the RBCs becomes carbonic acid. And carbonic acid is a weak acid that dissociates into H plus and bicarbonate. So the more CO2 you have in your body, the more acidic things become. The less CO2, the less acidic things become. Right, and we saw you can make the body more acidic if you hypoventilate. So like hypoventilate, meaning you breathe in much more slowly and shallowly. The CO2 builds up because you're not blowing it off. That's going to increase the CO2, increase acidity. If you hyperventilate, you blow off lots of CO2. Less CO2, you're going to become less acidic, more alkaline. Right, so by doubling, let me do this. By doubling your ventilation, like instead of breathing in half a liter per breath, you're breathing in a liter per breath, you can actually increase your pH by like 0.2. Become more alkaline. By having ventilation, which is going to increase CO2 because you're not blowing off the CO2, increase the acidity, you can decrease pH like by 0.2. Right, so by just breathing more deeply or breathing more shallowly, you can actually adjust your pH quite dramatically. Right, this is also, though, not going to be a permanent solution because you want to have more your baseline breathing, your tidal volume, and normal breath is about a half a liter in and out per breath, about 12 to 15 breaths per minute. So you don't want to have the rest of your life you're breathing in super deep and fast in order to maintain your pH balance. So this is still a short-term solution to keep your pH in the right zone. This, rather than being instant like the buffer systems, this is going to be over the course of minutes. As you change your ventilation, it's going to adjust to your pH. So respiratory system, this is over minutes. So you have this instantaneous buffer system that can make super quick adjustments, but with a limited capacity based on just how much of these buffer compounds are available. You have the respiratory system as the next level. By adjusting how deep or shallowly you're breathing, that will bring your pH up or down. This is when somebody freaks out and they're like really scared and breathing fast and deep. What's going to happen to them? What's happening to their pH?
It's going to increase.
Yeah, they're going to go into alkalosis. And so now they're getting all like off balance and dizzy and everything. What do you do for this person who's just been hyperventilating to try to bring their pH back into balance?
A bag, breathe into a bag.
Right, remember that's the classic thing, breathing into a bag. That's going to be concentrating. It's what you did in your lab, rebreathing, increasing the CO2. That's going to bring your pH back down and back into its target range. That's why they have people breathe into a bag if they've been hyperventilating, is to increase the CO2 in their body and bring the pH back down, because hyperventilation is going to throw you into alkalosis. So right? So, and then finally, what is our final long-term control of pH in the body?
I bet it's got to do with the kidneys.
Urinary system, right? You know, ultimately, you can secrete H pluses or bicarbonates. Can keep or excrete H plus or HCO3 minus. Right, so this is actually the only way to ultimately get rid of kind of acids permanently from your body. You know, these other things are kind of temporary ways to adjust, but the urinary system can actually just take the acids and pee them out, and now they're kind of watering a tree or going down the toilet or something rather than being in your body to maintain your pH balance. So the urinary system, though, obviously is not instant. This is like over the course of like a half an hour, right? So this takes longer. These other things can keep you in the target zone in the meantime, but ultimately the kidneys are going to be the things that are either holding on to or excreting, like, you know, metabolic acids to keep your overall pH in its homeostatic target range. So does that make sense? So again, very important role of the kidneys is your pH balance. Just like your kidneys are actually the ultimate long-term control of your blood pressure by adjusting water, they're the ultimate long-term control of your pH by adjusting how much or how little acids end up getting excreted in your urine. So any comments, questions about pH balance in the body? Right, so it's like you've seen all of these, but now we're kind of putting them together and seeing how they all kind of function and on different time scales. Super fast, relatively fast, long, but urinary system is ultimately the thing that can make permanent changes in your pH in your body versus these other ones that can make temporary changes in the moment but can't sustain them forever. So they can adjust things long enough so the kidneys have a chance to make the long-term adjustments. Okay. Water balance. So here's you. Yep. Water's coming in. Water's coming out. Ultimately, it's got to be pretty balanced, or else you're going to be slowly inflating and becoming a water balloon, or slowly desiccating and becoming a dried out husk. Right? So water balance is the amount of water coming in, the amount of water coming out ultimately has to be the same. Typically, it's about 2.5 liters. Water entering, water leaving. So let's talk a little about where the water is coming in from and where the water is leaving from, just so you have a sense of this. What are the ways that water is entering your body?
Respiration.
Yeah, so actually about 10% is cellular respiration. Normally people don't actually get that right away. That was actually good. If you all remember, What is one of the byproducts of cellular respiration?
Water.
Water, right? CO2 and water. In your mitochondria, every time you break down a sugar, you're making 6 water molecules. That water actually is non-trivial in terms of how much water it's adding to your overall water balance. It's adding about 10% of your water that's being added on the plus side of the balance sheet every day. In some little creatures, like the little kangaroo rats in the desert, this metabolic water is some of all they need. They're so efficient in holding on to the other parts of their water. This is like a major part of the water that they're getting into their body each day. For us, it's about 10%. Where else does water enter? How else does water enter the body?
Respiratory.
That's actually going to be on the negative side of the balance. If you remember, when you breathed onto the
Oh yeah.
pain, you actually had the water leaving your body. So actually, you know, on this negative side, we're going to have maybe 30%, lungs and skin, we're going to be losing as we evaporate, either through our breathing out, and also, even though our skin's relatively waterproof, it's still losing water to a small degree. What's the obvious way we're getting water into our body?
Drinking.
Drinking, yeah. So, and I'm going to give you a kind of, depends on obviously how much you eat and drink, but typically somewhere around 60% are just the liquids that you're drinking. 30% is like water and more solid foods. Unless you're eating like some total dried out cracker, most solid foods also have some water in them. So, the water coming into your body is either through the actual liquids you're drinking or through the water contained in the solid foods that you're eating. And then again, some from the cellular respiration. The water that's leaving your body, again, lungs and skin. So this is stuff you can't really stop, right? By the nature of breathing out, you're losing water from your body. Your skin has these kind of waterproofing glycolipids that keep your skin relatively waterproof, but it's not totally waterproof. So there's some water that escapes just through the skin. It's way better than if you were like a frog or something. If you're a frog, you literally evaporate at the same rate as if you were just like an open bowl of water. Other ways you lose water through perspiration. Obviously, that's going to depend on how much you're sweating, what your body needs to do to maintain its body heat. If you're sweating more, you're going to lose a lot more through this way. You're going to have to bring in a lot more in order to keep your water balance, right? That's why you need to drink a lot more water when you're sweating or it's really hot outside, because otherwise you're going to dehydrate. I'm going to say about 4% in feces. We're going to talk more about feces. Your poop actually has to have some water in it, or else you're going to be constipated and it's going to be bad. You need to have some moistness, some kind of bulk to kind of squeeze it out. And then obviously, maybe 60% in your urine, something around that. Again, this you can adjust as well, it's going to depend on how much you've been drinking, right? Everything here is going to depend. If you've been drinking more, you're going to have to be making more urine to maintain your water balance. This is just kind of giving you a sense of what are the inputs, what are the outputs. And one of the big take-home messages is some of this stuff you can control and some you can't. You cannot control the amount you're losing through breathing, for instance. or through just your evaporation through your skin. There's this idea of insensible water loss. No matter how much your kidneys are trying to conserve water and decrease the amount of urine, you're still going to be losing around 1 liter per day of water due to these ways that water leaves your body that you can't stop. And you also need to have some minimal amount of urine, or else you can't excrete stuff, right? If you want to get waste products and stuff out of your body, there has to be some minimal amount of water to actually have some pee to actually get it out of your body, or else it's never going to leave. So your kidneys can't conserve every last drop, because then there'll be nothing left to carry the stuff out of your body. So you have to have some minimal amount of urine you're producing, some vehicle to carry the stuff out of your body. You've got water lost through your lungs and skin that you can't stop. So this insensible water loss means even if you want to, you cannot stop water loss. And within a few days, you're going to be dead if you don't drink anything. Like for food, you have lots of storage, like calories and stuff in your body. If everybody in this class stopped eating for the next month, and you're just looking around, everybody's healthy enough that you would be very miserable, but you wouldn't die. And in fact, there'd probably be no, you'd probably be okay at the end of it all. Just a lot, pretty emaciated. But if you did not drink for a week, pretty much everybody in this Zoom group would be dead. Because you don't have the ability to replace that water that's going away, and your blood is just going to turn to sludge. So, that's, staying hydrated is important because of this insensible water loss. Right. In fact, that I don't know if people have been following the news, particularly like with the weather getting hotter and stuff. Like that family that was like this couple and their dog that were found dead on some trail like a few months ago, when they were trying to figure out what happened. And it seems like it just got really hot and they didn't have enough water, and they just all died of dehydration on the trail. So you definitely, particularly with global warming and with weather getting hotter than people used to remember it, staying hydrated is always a good thing. So anyway, that's all I really want to say about water balance. It is about balance. Some of it comes from cellular respiration. Most of it comes from your intake of food and liquids. Some of it you can control, like with your kidneys, but then some of it you can't control, that insensible water loss. So that's important to realize, that even at the very best that your body's doing to conserve water, if you don't have much coming in, you are going to be going into a deficit and dehydrating. So that's it. Any comments or questions about water balance? You can overdo it. Like there's some people get into this thing of like, oh my God, then I should just drink a lot all the time. You can overwhelm your kidneys' ability to do water balance and dilute yourself so much that you're, some of the words you might have heard: hypokalemia, hyponatremia, hypokalemia, K, that's not enough potassium. Hyponatremia, not enough sodium concentration. If you dilute yourself so much by drinking, like, there were some You know, the kids at the raves, like, okay, oh, I don't want to get dehydrated, so I better just drink a lot. They drank so much, or some of these challenges from these radio shows where drinking so much water so fast that you overwhelm your kidney's ability to maintain a water balance, and you dilute your concentrations of sodium and potassium so much that you mess up the resting potentials and the ability of your heart muscles to have the proper action potentials to have your contractions, and then you die because your neural messages and your muscle contractions all go haywire, right? You have to have the appropriate concentrations of sodium and potassium to have all those action potentials and cellular signaling with your neurons and your muscles. So you don't want to overdo it. You can kill yourself by just drinking so much that you dilute yourself beyond your ability to adjust. So, you know, don't go crazy. But also, yeah, so, you know, there's, you know, moderation. Stay hydrated, but like, don't like think you have like, don't think that it's impossible to drink too much, because people kill themselves by getting crazy drinking too much water. But probably in the big picture, more people don't drink enough water. So anyway.
There's been some stuff in the news from time to time, like there'll be hazing rituals, you know, at some college where a bunch of people think, well, we can't ask this guy, or we already did ask this guy to drink too much alcohol, but let's give him too much water, and it's a challenge, and they'll have some guy, or girl, but usually guy, and give them just gallons, and it's how much they can drink, and they drink until they basically pass out from water, and then occasionally they drink too much water and die right then and there that night.
Yikes. Yeah, hazing has got, yeah, can get really ugly. But speaking of drinking in water, I can recommend, remember we talked about ADH. If you're drinking alcohol inhibits the release of ADH. What does that mean?
More water loss.
More water loss. So if you have been drinking alcohol before you go to bed, what's a good idea?
Go to the bathroom first.
No,
Drink
but
lots of water.
yeah, before you go to bed, it probably makes sense to hydrate. Like, if you're gonna feel probably a lot better in the morning if you drink water and take a couple of aspirin before you go to bed. Just kind of, you know, I think it's a good strategy, especially as a college kid. Drinking water and taking a couple of aspirin before you go to bed. You'll probably not hate life in the morning as much, because being dehydrated feels crappy.